My guest today is Markus Heimbach. Markus is the Executive Vice President and the Managing Director at Hitachi Energy for high voltage products and systems. Markus, welcome. Thank you.
Thank you very much. Welcome, Alan.
So here's the thing. We're going to talk about something that is, yes, it's high voltage, but it's really not. But before we get there, I've got to ask you, when did you become a Picasso lover? I mean, with the art behind you, did you do that, or is that something that you purchased and it's very expensive art?
I do have to say, first of all, it's not me personally, but it was my wife. It was a present to my wife. It's a German expressionist, which is called Hartmut Ritzerfeld.
Okay.
Who is a pupil of a very famous German artist who is called Joseph Beuys.
Okay, good. Because I needed to know that, because I'm behind every good engineer or technical person is a spouse who makes them better. So you've got that down. I want to talk about SF6. I know that Thomas from your company is part of a panel. We just actually published something on a panel that's happening at a conference called TechCon. John McDonald is hosting it. But I want to talk about that. But before we get there, I want to talk a little bit about your background. I know you were with ABB for 20 some odd years prior to the Hitachi ABB transformation, correct? So how long, but in your current role, how long have you been doing that?
So I've been with ABB for more than 25 years in the whole history. And in my current role, I have been now there for roughly four years.
Okay, excellent. Yeah. So you've got a great background in high voltage systems. You've got a great background in when we started using SF6 gas, because that's specifically what I want to talk about. SF6, people may not know it, but it has been a brilliant insulator for a lot of primarily breakers, but a lot of products. Tell me a little bit about when SF6 first came on the market. What was the thinking back then? Why so much SF6 in the market?
So as you already said, SF6 is a brilliant gas when it comes to insulation. Yeah. And it basically helps the high voltage products to become more and more compact, to reduce the footprint. And what is very often forgotten, SF6 is not only very good when it comes to insulation, SF6 is as well a brilliant gas when it comes to arc quenching, or basically interruption, which is the primary goal of every circuit breaker.
Right.
So with these two excellent possibilities that SF6 provides, it was a revolution in the high voltage industry to make the whole equipment more cost efficient, smaller, more compact, and as well reduce the footprint for the substations. Excellent. And was as well enabling to build a so-called gas insulated switchgear, which is taking away basically 95% of the complete footprint in 3 dimensions away compared to an AIS, an air insulated substation or switchgear.
So we know it was a revolution and it was great. However, on the flip side, there's a problem with SF6 now. Talk a little bit about that.
Yeah, and as you rightly said, so we have these two brilliant properties of SF6, meaning the insulation and the interruption. But on the other hand, SF6 is one of the most potent greenhouse gases. It has a global warming potential in the range of 25,000. It stays in the atmosphere for more than 3,000 years. Even though the overall contribution of SF6 to the global warming is not super high percentage-wise, but it's still in the range below 0.5%. And considering the use of SF6, which is really minor, it is not negligible. So there has been a huge pressure over the last decades, which is now increasing with all the global warming and discussion and COP discussions we have all over the world, to phase out SF6 in order to reduce this greenhouse gas.
So I said when we first talked or when we first met, I said, it seems like there's a lot of different companies that are approaching it. And my concern was that we had different standards and the ultimate end user was going to be confused about how do you replace SF6. But you were very clear to say, no, we are all adhering to developing a standard. Talk a little bit about the standard for that was developed for all of the companies that are including Hitachi Energy, that are creating alternatives for SF6.
So let me put it a little bit differently. So there has been for sure, in the beginning, we can roughly say we have a couple, mainly 3 global competitors working in that space in the high voltage products. In the beginning, in the very beginning, 3 of them had a different solution. So everybody had a different solution. So then going forward, we were then looking in what could be the best for the industry. And somehow we then came together between General Electric and us to embark on a very similar solution, which has the basic background. It's for sure different when it comes to the breaker itself. It's different when it comes to the switchgear itself, but it's basically using the same solution like SF6 was a similar solution for the industry. This, I do believe, is important going forward for the customer because the customer doesn't want to deal with the complexity of every supplier has a different solution. So from that point of view, this was a move to as well to enable a faster transition of the whole SF6 phase out.
So looking at things from that perspective of the standpoint of the end users, the practitioner, what are the things that they should be thinking about? Because, you just said it, there are 3 main people working on it. As they're replacing SF6, what are the things that they should consider with these major changes going on?
Alan, what you were saying in the beginning, you are as well part of a reliability engineering group and so on. I think the first and foremost, it is that the solution has to be as reliable as SF6 solution is today. Otherwise, we cannot provide the reliability to the equipment, the reliability to the overall grid, and the security of people getting the electricity. So this is the first and foremost thing we have to look into it. Secondly, we need to find a solution which is, or we need to strike a balance between a gas which is good at interruption, it's good at insulation, but it's significantly better than SF6 when it comes to the global warming potential. And this basically describes that in the end of the day, we need to have as well a solution which somehow fits into the footprint of the former substation, because, mind you, SF6 was invented because it could reduce heavily the footprint. And last but not least, it should be a solution which is scalable, a solution where you can have an interruption or a breaker which is working at 123 kilovolt, but it's as well working beyond 420 kilovolt. And that basically points very much in the direction of a gas circuit breaker, because there you have the linearity of the gas, which we are using as well very much in the whole SF6 story.
So SF6 is kind of ubiquitous. You hear it, everybody says, oh, that's the same. Now with different gases, are they interchangeable for the end user? Is there a way to say, hey, I'll have some that I'm interchanging in this part of the world, or are they unique and they have the end user has to remember, wait a minute, I'm going with the Hitachi solution, and then that has to happen throughout their system. Are they interchangeable gases?
So first of all, what is in this big transition, we are not going from one gas to another gas. We are going from a gas to a gas mixture. We are using the CO2, which is the second best gas when it comes to interruption, for the interruption. We are using a gas which is called C4 fluoronitrals for basically improving the insulation performance of the CO2, which is the main gas, or the carrier gas as we call it, and then we need a little bit of O2 in order to prevent soot after switching. So that is basically the gas mixture we are having. When we have our solution, meaning Hitachi Energy, it is the same mixture or similar mixture that GE is using. So the gas is interchangeable. The equipment from the customer to maintain the gas filling and all these things, which is very important for the customer, it's a similar solution between these two companies.
Okay. So that makes it a lot easier. But when we say SF6 gas, there's one. What are we going to call this? Just new gas? What has Hitachi named their solution?
So we call our solution, we call every solution which is giving a quantum leap in environmental friendliness, we call it iconic. So our solution is called the iconic solution.
Okay, so I want to hear that iconic, ECONIC.
With a very close, the last one is a Q in order to underline the quality and the reliability, which I was meaning in the beginning. I was pointing at in the beginning.
Plus, it ends with IQ, right? It's smarter. It's a smarter, better gas.
Correct.
I'd like to talk to the marketing people who came up with that. So this is really brilliant. I really appreciate you sharing the insight, because right now there is a lot going on in the high voltage world. There's a lot going on in the utility world, and being able to have companies work together to solve a problem is the only way that we're going to solve the problem. There will be no one proprietary solution for the most part, right? And the fact that the companies have worked together to create a solution, thinking of the end user in there. So I want you to, again, put your utility practitioner hat on. As I'm planning to do this, or as you're planning to do this, as you're thinking about it, timeline, what is it going to take to be able to change the equipment out? Because you said there's already a footprint that you've got to fit into, correct?
Yeah.
Yeah. What is the normal utility timeline for changing things out?
Look, let me put it first of all, like, let me start a little bit different.
Okay.
When we have in the moment, it's a huge challenge for us. And you rightly said cannot be done by just one company. It is a huge challenge for us to develop a portfolio. In the end of the day, we need to have a portfolio which is matching the whole SF6 portfolio in all the voltage ranges, interruption current ranges, which have been developed, as we all know, for decades.
Right.
And now we have a huge pressure to phase out SF6 mainly within this decade very soon to an 80-20 approach, at least in Europe. And I likely assume this very similar topics in the US. So it is a huge effort to have now a lot of good people who are able to develop this new solution. When it comes now to the timeline from a utility point of view, is that we are in the moment undergoing the last type test for a 420 kV solution.
Okay.
Meaning that and we have sold already prototypes and pilots, both to the Eversource, for example, from the DTB side, the tank breaker side into the US. We have sold as well to TenneT or to National Grid, TSOs in Europe, 420 kV GIS base, which will be installed somewhere everything will be installed between the middle of this year and towards the end of next year.
Excellent.
And so what we can basically saying is we are now about to industrialize the whole solution, and that we can now ramp up our offering of this solution so that we can provide the market according to the needs SF6 switchgear as soon as possible, and then as well across the voltage range.
Okay.
And our overall goal is that we have the whole portfolio developed somewhere in the range of 2025. So in 3 years from now.
And then that amount of time that it takes for people, I mean, that's still a very aggressive solution, time-wise, a very aggressive solution, which I applaud Hitachi Energy and your peers who have worked on this, because sometimes these solutions get talked about, but they're not practical to implement. And you've got a practical implementation of that. I appreciate that. So any last comments about either the art behind you or your work at Hitachi Energy or the replacement for SF6 gas before we go?
Maybe one last, not about the art this time, but because of our people. I mean, it's only possible, and this is very often underestimated.
Right.
This huge transformation which we are doing here in Hitachi Energy, being the spearhead of the industry in going on this exchange, is only possible when you have really brilliant people in your team, and when you have as well people who are not only brilliant, but they're as well working as one team, because you cannot afford to have people going in different directions. You need to have a seamless approach going forward. And what helps us here very much is it is not just the technical challenge of building up a portfolio SF6 free, it is as well something good for the people, that they do something good for the society. And this is a huge motivation, which is then making everybody able to go the extra mile, to go according to the roadmap we have defined ourselves. And we know, and appreciate that you're commenting, is how aggressive it is.
You know, one of the things that the next generation, and I don't mean 20 somethings, I mean engineers, it's been hard to get them into the utility world. They all like to do, you know, electronics and things. So electrical engineers, but the next generation, it seems, has something in common. They want to make the world a better place. And what you have done and what you are doing does that. So anybody who's thinking about going into this industry, work with people that make the world a better place. But thank you for doing that, Markus. You're one of the leaders that leads that, and I appreciate that very much.
Thank you very much, Alan. It was a pleasure to talk to you.